I understand that your dad developed the prototype for this and had it working in the Lake District.
Yes, that's correct. My father invented the pump in the early 1980s, and we used to see early prototypes of the pump, which we used to be spurting out water in the garden. In fact, my father used it as a garden fountain for many, many years. Whilst my father was able to get it to work and came up with the idea, computing software wasn't really the standard it is today. So he managed to get it to work, but didn't really understand the physics behind how it actually worked. And of course today computational fluid dynamics has improved immensely, and John and his team have done a marvellous job in terms of getting to understand how it works so that the improvement of the pump can be worked on, which is the reason why we're looking for funding now, so that we can firstly we can optimise the performance of the pump and do some field testing out in Africa.
My name's John Allport. I'm Professor of Automotive Engineering and Director of the Turbocharger Research Institute here at the University of Huddersfield. And we've been working on a solar power pump for irrigation purposes in Africa. You might wonder what a group from a turbocharger engineering team are doing working on solar powered pumps. But there's a lot of synergies between the thermodynamics, the materials and the fluid flow, and particularly the computational fluid dynamics that go into both types of apparatus. So we're looking at aerodynamics in turbochargers, but we're looking at similar thing with water and with heat transfer in the solar powered pumps.
From our point of view at the centre, one of the things that we're excited about here is the fact that it is dealing with a renewable technology, but also the fact that the design is such that there's no moving parts, that it's a very, although the physics is complicated, it is simple, and it's using kind of products that could be bought in Africa, found locally very easily, which I think also makes it a lot more sustainable from the point of view of communities out there. And the other thing is that, of course, it's really cheap because it's using renewable energy. It's not, other than the cost of the kit in the first instance, it's not going to cost a community ongoing resources, scarce resources, to kind of keep something like that running. And it may also be something that would mean, because of the reliability of it, that it's providing a much better system for people, and has the potential maybe to either expand the areas that they kind of cultivate,